I'm Bob Finch with Select Spectrum. We'll be talking about an introduction to dual unified efficient transmission, Duet. So dual unified efficient transmission, that's our acronym. Others call it other things, as I'll show. The use of two different frequency bands to get overall a more cost-effective and better solution to private network requirements, private wireless network requirements. And I'll describe why that can be the case. I guess one reason to look at this, of course, is that this is the predominant strategy, or it's a version of the predominant strategy that's used by carriers around the world. Here in the United States, T-Mobile calls this layer cake. They actually have a 3-layer cake. We're going to recommend dual approach, but many of the same situations in terms of the low band coverage on a broad area and the mid band coverage for capacity and broadband support are quite relevant. So as you think about building a private network, what are some of the requirements you might have? You might need wide area coverage of a large area. We'll show later a coverage of the majority of a whole state. You might have large numbers of endpoints, but you might also have the need for broadband speed for some, but not necessarily all of those endpoints. And for example, if you're doing a transfer trip operation for an electric utility, or the most sensitive one is a sensing for a falling conductor and shutting that conductor off prior to it hitting the ground and starting a brush fire, you need very low latency, and that's going to require broadband. It's not necessarily available on the lower speeds. So the lower frequency and potentially using a technology that is lower throughput but longer range provides broad coverage of a large area. And the higher frequency, the mid-band frequency in this case, would be used to provide capacity where it's needed. And that's really the idea of having the right tool for the right situation will be lead to a better overall architecture. So let's take a look at this in a particular case. We picked Harrisburg, Pennsylvania as an example location. And if it's not possible to get complete sense of this, but the downtown is really pretty concentrated. Within about a 2-mile radius of the center of downtown, you cover the majority of the most urban area in Harrisburg. And you could do that, in our view, using CBRS frequencies, and you could do that with something with a single tower within a 2-mile range. Some people would say up to 3, kind of depends upon the specifics of the link and how much throughput you're trying to get. But broadband service, 10 megahertz is what the CBRS channels are, and over about a 2-mile range. There are some power limits that make CBRS more limited than some of the other mid-band frequencies that are available. So good for a relatively small area. If your coverage needs are greater, then we believe typically in a city like Harrisburg, a 6-mile radius should be possible on 1.6 gigahertz broadband. So this 1.6 gigahertz relatively newly available to the market. It's a time division duplex, meaning transmit and receiver on the same frequencies and alternating back and forth, but on a very high rate. Provide excellent throughput. Part of the 4G, it's in the 4G standards process. It'll be ultimately, we think, a 5G standard as well, and it's available throughout the country. So both of these frequencies widely available. The CBRS is in many cases shared, and in some cases you can also acquire your own license for these frequencies. So depending on what area you want to cover, you might be attracted to one of these or the other. But you'll see, it doesn't cover the entire, we say roughly 25 miles that could be done using 700 megahertz NB-IoT. So 700 megahertz is an excellent propagating frequency, but even more importantly, to get this long range, NB-IoT is a standard that's specifically designed for broad coverage and to support Internet of Things type applications. So because of that, it can tolerate transmission issues, propagation issues, interference issues even that would not be acceptable in other types of technology. And for that reason, we think that NB-IoT, and combined with any sub 1 gigahertz frequency, but the one that's most broadly available at this point is 700 megahertz A block, could be a way to provide the broad coverage of a given metro area. Or if you want to extend that on a statewide basis, here we show an example of the state of Pennsylvania, fairly large for an East Coast state. And you can see that with, I believe this is 19 different towers, you could have coverage of the majority of the state with just that number of towers. Now, this is not an engineered design. One could argue that if you get over into the Pittsburgh area where it's quite mountainous, these circles would be smaller. But on average, this will provide broad coverage over this kind of distances. And you see, in general, it's complete coverage in this area. Here you show one little small gap. But this would be considered as region-wide coverage using 700 megahertz, using NB-IoT. What that may not be adequate for particular applications. So if there are locations where you need to provide broadband services for the reasons mentioned on the left or that I mentioned before. So high-speed video, very high-speed data, lots and lots of devices in a concentrated area. These are places where you just need more capacity and lower latency. So it would be possible. And using Duet, the concept is same tower, same base station, same supplier, probably different antennas. And in the transmit and receive link, there'd be some different filters and amplifiers and receivers and so forth. But you're reusing a lot of the technology. You can mount your broadband along with your narrowband capability and serve this dense area. So these areas are not small, right? 6 miles radius, pretty significant, would certainly cover, way more than a substation. I can't imagine a plant, industrial plant, requiring more than a single transmitter using the 1.6 gigahertz frequency, or multiple different devices spread over a more urban area, or for whatever reason, an area with higher demand. So this combination is really the essence of Duet. Broadband where you need it, pay for it where you need it. Even the spectrum potentially is really only purchasing it exactly where you need it. And with regards to coverage, you're depending upon a lower frequency and probably a technology that supports lower speed, but much longer transmission ranges. So this is the essence. It's what the carriers do. They, by the way, are using broadband typically even at the low frequencies, but they put the majority of their capacity, the vast majority of their demand is mid-band frequency these days, and over time they're trending to even higher frequencies. So wanted to describe, okay, what are the benefits? So first of all, Duet using the low frequency and NB-IoT or some lower modulation scheme will give you very long range. 25 miles we think is reasonable. You could do longer in certain situations, and so that limits the number of towers you have to build. Obviously, if you have the capacity demand, you're going to need to have shorter distances and higher frequencies. What does that do? It saves you money. You build broadband where you need it, where you can accept the capabilities of broad coverage. Lots of devices potentially, but not lots of very high throughput per device. And then finally, if you use a true version of Duet that uses 4G and 5G technologies, you're benefiting from all of the research and development that has gone into and is going into this worldwide standard used by billions of people, billions of devices. That really means literally trillions of dollars of investment over time. You don't have to make all that investment. The majority of it is done by chips makers, module makers, infrastructure makers, all of the different apps vendors that support them. And so the same chips and modules that can be used in a consumer device can in fact be incorporated into industrial devices to support the types of applications that you have. So as we think about what spectrum options might be there, with sub 1 gigahertz specifically focused on NB-IoT, there's really only one that I would recommend as being broadly available, and that's the upper 700 megahertz A block. In terms of the broadband, 900 megahertz is an option, so you certainly can look at that. We certainly recommend looking at 1.6 gigahertz band 105. By the way, we also represent Legato Networks. They have band 105, and they have a broadband, but band in band 24 as well, could be considered. And finally, CBRS. So this is available nationwide on a GAA basis. We have PALs available in several hundred counties around the country, and could match your needs. So please feel free to contact us about any of these bands, and we are representing sellers in 3 of the bands listed here. By the way, on CBRS, we've had separate webinars about that. So if you enjoy the webinar form of learning, I encourage you to check our webinar channel on YouTube. So with that, we're up to questions.